Today we are solving problem 15, which is three-sum problem. So what three-sum problem states, so we need to find, so we have a given array nums array, and we need to find all the subarrays, all the subsequences, not subarray. So all the subsequences whose sum is equal to 0. So here we need to find all such numbers in the given array, or any three number whose sum is equal to 0. So that is a simple problem statement which we are going to solve. So this is a medium level problem on the Leetcode, and we are trying to solve this problem. So let's first go to the brute force solution. So to find the sum of to find the three numbers whose sum is equal to 0, we can just simply run the three loops, um, j k. We will take first loop pointing to -1, second j is pointing to 0, and k is pointing to 1, and we will keep on iterating till we don't find any three number I, j, k whose sum is equal to 0. And if we find, we can just break it and we'll come out of all those three loops, and finally we'll get the array where we get. Since here we need to find all the array, we can't break it out. We need to keep on iterating till the array is not finished, so that we will get the all the pairs of three numbers whose sum is equal to 0. So the time complexity for the brute force solution will be big of n cube, because we are running three nested loops, and space complexity is constant space complexity because we are not using any space complexity. But yeah, time complexity is very worse because it is a big of n cube. So basically this is nothing but an extension of two sum problem, which is where we use hashing. So in this problem also, um, we can use hashing, but that will also will have a higher complexities. So this problem we can easily solve by sorting the given array and use the binary search. So binary search problem. So by using binary search as an algorithm. So let's go to the solution. So the crux behind this solution is, like, suppose we have given array, so we just need to find three numbers whose sum is equal to 0, or in sort of x. Suppose it's applicable to all the problems whose sum we need to find if the three number sum is some number. So here we need to find the three number whose sum is equal to 0, but it doesn't matter if we can point it to any x also. Suppose we need to find three number whose sum is 0, so we can say like a plus b plus c is equal to x, right? And we can also say like this, a plus b is equal to x minus c, right? Because so let's see example, it will become more clear. So 1 plus 2 plus 3 is equal to 6, right? And if we do 1 plus 2 is equal to 6 minus 3, so this is also equal, because 2 plus 1 is 3 and 6 minus 3 is 3. So this is also equal. So this is the logic which we are using in our algorithm. So what we are doing, we will first sort the array. Since we need to apply the binary search, we need the array must be sorted, otherwise we don't apply the binary search. So first we will sort the array. So after sorting, we will take one list of lists, since we need to return the all the list in the response. So we have taken the list of lists, and now we are running one for loop where we are iterating on our given array. And first of all, we need to see if I is greater than equal to 0, and nums is not equal to nums minus 1. So what this condition states. So first of all, what we need to do, since we don't want to duplicate here, like in the solution, if you see here say we don't need a duplicate triplet, so we need a unique set of values. So to get a unique set of values, we need to eliminate a duplicate values. So for that we have written this condition. So if nums of I, we are starting from 0, and nums of so this condition is only will work when I is greater than 0, because here we are doing nums of I, nums of I minus 1. If we not put this condition, we will get underflow error, because 0 minus 1 minus 1, and nums of minus 1, there is no minus 1 index, and we will get runtime exception. So for this we have given, and if I is equal to 0 also, so then also we'll do this. So this condition we have put to avoid a duplicate. If while taking any number from here, we are if that number is exists previously, so we will not take that number, we'll skip that thing. So that's why we are taking this. So suppose this we are doing for the our number c, because we need to take one number. So here suppose -1 we have taken, so -1 act as a c for us, and we need to subtract that c from our target. So here our target is 0, so we are subtracting that number from 0. See here, so we are calculating the sum where we are subtracting that number from 0. Okay, and we have taken the two pointer, which is low and high pointer. So low pointer is pointing to I-1, because this is our c, this is our c. Let me write it here so it will be more clear. This is our c, this is our a, and this is our b. Okay, so yeah, so low is, as you say, is pointing to I plus 1, and high is pointing to num minus length. B is here, num minus 1. So we need to just find out which is so B is here. So initially A is pointing to I plus 1 and B is pointing to n minus 1. And now we are running a while loop where low means A is less than, A index is less than equal to B. Till then we need to keep on iterating. And now we will see if nums of low plus nums of high means a plus b is equal to sum. If this is equal to sum means 1 plus 2 is equal to sum means is 6 minus 3. If it is true, then we will get one set of our solution where the three numbers sum is equal to 0. So we will get this solution, we will add all those numbers into the temp array, and we will add that temp array into the our resultant array. So if we get the sum is equal, if we not get sum equal, but we see like since we need to remove the duplicate, we don't want duplicate sets. So what we do, we will try to skip the duplicate value. So here we are running one more while loop, where till then where the low is less than equal to high, and nums of low is equal to nums of low plus 1. Means here a is pointing to 1, and 2 index is also same, so we increase the pointer. So now here we will increase the pointer, then a will move to here. If it is equal, we will try to skip those values, and same applies from the b also. If the values are equal, we will try to skip that, we will try to decrease, we will try to decrease this index, we will try to increase this index for low value, we try to decrease this index for high value. So we keep on doing this to avoid the duplicate values. And yeah, and once we will done this, we will just increase one count, and we'll keep on doing this till then we will not find our sum number. So if it is equal to sum means we will get our number. If there is some duplicate, we'll skip those two duplicate, and we increase to point to the next number. If it sum is not found, so we will see if sum is less than sum, then we will do our low index will increase. If sum is greater than this, then we'll decrease the high index. Since it is sorted, so we will get this. So it is simply bugging as a binary search problem. If you know the binary search algorithm, you will easily understand the uh, logic in this. This is a simple binary search problem which we have done after sorting of this array. So yeah, so this is a simple solution for this tsum problem. Let's run once and see. Should work fine. Let's nums array. Yeah, so it is working. So yeah, that's all for this problem. Thank you. Happy coding.